Hello again. This is a video on function transformations, graphing the transformations given the function. The common theme in mathematics is that we are going from the graph to the equation, and then sometimes we're going from the equation to the graph. And when we say graph, that can be information about the graph, not necessarily the graph itself. So we might want to find out certain information about a graph from the equation. Like for instance, for a parabola, we might want to know what's the vertex. So this is a common theme in mathematics, and this is the second part. If you've viewed my other video on function transformations, we were finding the equation. So we were given the graph, and we were finding the equation. In this case, we're given the equation, and now we're going to try and find the graph. And the process is going to be very similar to what I did before if you viewed that other video. We're going to begin with what's the parent function. What's the parent function from our library of functions? So in this case, it's radical. And I'm going to graph that. And I'm going to say, here's the radical function. So I know that the radical function has 0, 0, 1, 1, and 4, 2. And then it curves like that. And actually, I want that to be dashed, a little bit dashed, because that's not my final graph. So I'm going to go ahead and just make some eraser marks here and dash this. Okay, next, the next thing that I want to do is I want to take the reflection. And this should be something that's in your notes, is that you say, when you're doing these, you are going to take reflections first. Okay, so here I've got a reflection. If you look at the equation, and I'm going to circle it, I've got that reflection. So hopefully you know that that reflection means that we're reflecting through the y-axis. So I'm going to take the graph here, and I'm going to reflect it through the y-axis. Like so. All right. Again, like I did in the previous video, I could kind of keep track of where I'm at here, right? I could say, like right now, if I said f of x is equal to rad x, so here's f of x, that's the rad x, and then here is negative f of x. That's actually not negative f of x, error. Let's say that's f of negative x. That's f of negative x. So this f of negative x here, f of negative x, that's taking into account this negative. So it may be confusing for you to jump back and forth between talking about the expression like this and talking about the expression in terms of f. But you need to be able to do that. Really, we need to be able to talk in terms of f, and those need to be interchangeable, that I can talk about f or I can talk about the expression for f, which in this case is the radical. So I'm going to keep talking in f, using f and function notation, even though you might not be totally comfortable with that. All right, so I've taken the reflection first, and then now I want to do the next thing that I would like to do is second, and we don't see very many of these, to be honest, but second is take the vertical or horizontal, actually there's one word for that. Let me just use the one word. It's a non-rigid transformation. So I want to take the non-rigid transformation next. So take and actually maybe you could take that first actually. Take non-rigid next. And that'll work fine, either order. But these two definitely have to come first before you do your vertical shift or horizontal shift. So the non-rigid transformation here says 1/2. All right, well that's easy enough. I'm just going to cut all my y values to 1/2. So I'm going to bring this down. If you can see, it's going to be, I'll try and be as clear as I can on it. Maybe I'll do a different color. and a little bit bigger. So half and half. If I go up here to 2, 1, half, right there. All right, so all those y-coordinates, if you can see the blue to the left of the y-axis, those are all half. So I'm trying to cut it down, achieve the this 1/2. What does it do? It's a horizontal shrink. I'm actually going to leave that note up here on this problem. This 1/2, I'm not horizontal, vertical. It's a vertical shrink. Vertical shrink. And again, if you're not familiar enough with that, go back and watch the video on Introduction to Transformations. All right, so I've got the reflections, I've got the non-rigid transformation. Now I'm going to do the shift, and this is always going to be the easy part, right? So now what is this telling us? This is telling us, oh, well, in this case, it's not the easy part. You need to be careful with this shift, because if you've watched a previous video on function transformations finding the equation, you know that you can get tripped up here if you don't factor out this negative. Okay, and again, I said in the previous video, this really only comes up with these radical functions. Pretty sure that's the only case where you can get tripped up by this. At least the only case that you're going to see in a pre-calculus class, typically. Okay, so let's go ahead and factor that out. So I've got 1/2 radical, and then that's negative, parentheses, x minus 1. I factored out the negative. That has to happen because that's the only way that I can see that this is the horizontal shift. The horizontal shift is 1 to the right. Okay? So we'll finish the graph up. And I'll just choose a different color and do a horizontal shift. 1 to the right. And that'll be our final graph right there. Okay, so hopefully now you have an idea about how to do a function transformation where you're looking for the graph, and you have an idea about how that relates to a function transformation if you're looking for the equation, which is on the other video, the companion video to this.